Hello everyone. The protective relays are mainly classified as electromagnetic type, static type, and microprocessor based relays. The electromagnetic attraction type and electromagnetic induction type relays are discussed in the last video. Now we can see static relays and microprocessor based relays. From the name itself, we can say that static relays does not require any moving parts. It uses static components. The main advantages of static relays are the components required is static devices like op amps. The power required to provide for the relay is very small value as the power required for static devices is less. There will be amplification, there should be amplification of energizing signals that requires small amount of power. Therefore, the size of the associated current and voltage transformer can be reduced. And by using static relays, we can improve the accuracy and selectivity of the relay. The fast operation of the relay is fast, and hence the fast clearance of the fault occurs. And as it is static relay, we can change the characteristics by changing the resistor or capacitor values in the relay. So there is flexibility of the circuit, and the relay would be unaffected by number of operation. It will not change its properties with number of operation. The main limitation of static relays are auxiliary voltage requirement for the relay. Additional voltage is required for amplification of the signal. Then static relays are sensitive to voltage transient which are caused by operation of breaker and isolator in the primary circuit of current and power potential transformer. It may operation of the relay is affected by the transients in the current and potential transformer. Then non-availability of test data. Highly reliable power supply is required. Now we can see block diagram of static relay. A static relay mainly consists of a rectifier. As this static components like op amps will work suitably in DC values, there will be a rectifier for converting AC quantity to DC quantity. Then there is a measuring circuit of the relay, that will be a comparator. Then amplifier, the output of the comparator. The comparator is the main part of the relay which compares the or which detects the faults, and amplifier will amplify the output of the comparator, and it is given to the output trip circuit so that the circuit breaker will operate. And there should be DC supply for the amplifier, comparator, and also for the output trip circuit. So main part of the static relay is a comparator where the normal and faulty condition is compared. So a comparator, the magnitude of voltage and current and phase angle between them may change when a fault occurs. So static relay senses the change in these parameters to differentiate between normal and faulty condition. This is achieved by comparing either magnitude of voltage or current or phase angle between them. The circuit which performs this comparison of voltage or current or phase angle during normal and faulty condition is called comparator. There are mainly two types of comparators, amplitude comparator and phase comparator. Amplitude comparator compares the magnitude of two input quantities. It will not look into the phase angle between them. Two quantities are called operating quantity and a restraining quantity. Operating quantity is the quantity which is measured from the line to be protected. So magnitude of the operating quantity is greater than the restraining quantity during normal operating quantity is greater than the restraining quantity when the fault occurs. Then the relay sends a trip signal to the circuit breaker. During normal condition, operating quantity will be less than the restraining quantity. There are mainly two types of amplitude comparator: circulating current comparator and opposed voltage comparator. First one is circulating current comparator. In circulating current comparator, there are two current values: I0 operating current, IR restraining current. And it is given through two current transformers and is given to a rectifier, and there is a relay element where the current flows in one direction, that is negative direction from here to here, if IR is greater than IO. Under normal condition, restraining quantity will be higher than operating quantity and current flows in negative direction. When fault occurs, operating current increases. So IO will be more than IR. So current entering here, IO will be more than IR. So the current direction in the relay coil changes. Differential current flows through the relay in positive direction to trip the circuit. When the current direction changes in the relay coil, it sends a trip signal to the circuit breaker and the circuit breaker will operate. So there is current transformer, rectifier, and two quantities are there: operating quantity and restraining quantity. Depending on the magnitude of operating quantity, the fault condition is identified, and during the fault condition, the current direction changes and it sends a trip signal to the circuit breaker. Next is opposed voltage comparator. In opposite voltage comparator also similar theory is used. Only difference is here voltage is applied. Voltage is the quantity. So there is operating voltage and restraining voltage. Normal condition, operating voltage will be null, VR will be greater than VO, and the circuit connection is as the voltage is given, circuit connection has some changes. The relay is connected in series. So when this voltage is higher, VR is higher than VO, then the current flows in one direction, this negative direction. When VO is greater than VR, current flows in opposite direction and sends the trip signal to the circuit breaker. Here also there is rectifier arrangement for converting AC quantity to DC quantity. Next is phase comparator. In the phase comparator, period of coincidence of positive polarity of two signals are compared with some reference angle, usually 90 degree. So if there are two quantities, the period of coincidence of two quantities, this angle is measured. If two signals have a phase difference of phi, then the angle is 180 minus phi. If phi less than 90 degree, then psi greater than 90 degree. The phase comparator may be designed to trip the circuit breaker when psi is greater than 90 degree. The period of coincidence is measured by different techniques. So, if two quantities are there, the period of coincidence, if the period of coincidence psi is greater than 90 degree, then it detects the fault or it may send the trip signal to the circuit breaker. The period of coincidence is measured by different techniques. So different techniques or different types of phase comparator are vector product phase comparator, coincidence type phase comparator. Vector product type are Hall effect, magneto-resistive. Coincidence type are block spike phase comparator, splitting phase comparator, integrating phase comparator, and rectifier bridge type phase comparator. So first we can see block and spike phase comparator. Here in this method, one of the two input signal is converted into a square wave and the other is converted into spike during its peak. So if there are two signals, one signal is converted into rectangular pulse and another is converted to spike at its peak point. This Ki is converted to spike at this peak point 90 degree. Then voltage signal is converted into square wave. And these two signals are compared or it is given to an AND logic gate. When for the AND logic gates, the output will be present only if both the signals are there. Both the signals are there. So output will be there when V and K is there. The coincidence will happen only when the angle between the input signal are less than 90 degree, which indicates the fault. The output of AND gate is used to trip the circuit breaker. So here also coincidence angle psi is measured. If psi is less than 90 degree, which indicates that there is a coincidence. Spike and the square wave will coincide. If it is greater than 90 degree, coincidence angle, if input signals coincidence angle is greater than 90 degree, there is no coincidence or there is no output for logic AND gate. Then next is phase splitting comparator. In this method, two phase shifted signals are given. If current is there, current and voltage signals are there, current signal is multiplied by a particular constant to get to have an input to the AND gate, and it is phase shifted by angle plus 45 and minus 45. This voltage signal also phase shifted by plus 45 and minus 45. These four components are fed into AND gate. And the output of AND gate will be obtained when all the signals are get coincide. So the trip signal will be obtained if the all signals are coincide. Now we can see different static relays depending on the applications. First is static overcurrent relays. Static overcurrent relay is as the name says, it is an overcurrent relay. It detects the faults depending on the current magnitude. When the current magnitude is greater than the set value, it will produce an output signal. So there is a current transformer with a filter, and it is given to a level detector where the level of the current signal, magnitude of the current signal is compared with pre-threshold value set by the relay. And when the fault occurs, the current value will be greater than the threshold value or the restraining quantity. And then the level detector will give an output. This output is amplified and is given to the output device, which gives trip signal to the circuit breaker. So if I input is less than threshold, output will be 0. And if I input is greater than threshold, it will send an output. Then this is simply measuring the current value and comparing with the threshold value. The next is definite time over current relay. Here there is a set time for the operation of relay. The time of operation of the relay is constant irrespective of the value of fault current. So here also there is input transformer, then rectifier with a filter, level detector which detect the fault level, current level, and in addition to that there is timing circuit. Timing circuit will determines the time of operation of the relay, and the level detector 2 or potentiometer, that is for setting the time of the circuit breaker, time of operation of the relay, and the output is given to the amplifier and the output device. So here we can set the time of operation of the relay. But if once we set the time of operation, it will work with same time irrespective of the input current. It does not depend on the fault current. The time depends on the settings we have given here in the timing circuit. This is called definite time over current relay. Another type is inverse definite time over current relay. In case of inverse definite time over current relay, the time of operation of the relay is depending on the current value. If the fault current is very low, time of operation will be large. If the fault current is very large, the time of operation will be very small. If the, as we know, if the fault current value is high, it may cause more damage to the system. So the fault should be cleared more quickly. So at that case, the time of operation is less. There is an inverse relation between the time of operation and the actuating quantity. So here there is input transformer, rectifier, level detector, and along with that there is switch S2 which determines the time of operation. This S2 works according to the input current. So, depending on the input current, there is RC timing circuit here. In the timing circuit, there is some capacity elements which is charged according to this current value. So, the timing of this circuit determined by the current value. This is called inverse definite time over current relay. Next is directional over current relay. Directional relay is nothing but the differential power relay which operates when the power circuit flows in a particular direction. It will detect the fault according to the direction of current. If the direction of current changes, it detects the fault. So there is an auxiliary current transformer, a phase shifter, and both are given to the phase comparator, or it is the directional unit. And there is also timing circuit for determining the time of operation, and it is given level detector, and the output is given to the amplifier and it produces the trip signal. So the input A is proportional to the system current and it is given to the directional unit through an auxiliary transformer. Input B is proportional to the system voltage and it is given to the directional unit through a phase shifter. The phase comparator compares the phase angle between these 2 points. So it requires the sensing the voltage and the current. So power flow direction is determined. It works based on the direction of power flow. Under normal condition, this is differential relay. This is directional relay and next is differential relay. In differential relay, under normal condition, current through two ends of the wire are same. If we are using the protection of alternator, winding we have at two ends of the winding we have same current during normal condition. But if there is a short in between the winding, the current at the two ends will be different. So for this type of application, differential relay is used. Currents at two ends of the line are measured. If there is a difference in current, normal case, both current, if it is a series connection, both currents at the two ends of the line will be equal and there is no uh, sum of summation of the current at the relay coil. But if there is some change fault in between the system, there will be change in the current at the two ends of the line, and it is measured by the differential relay. In this relay, two similar input quantities are used. It can be current or voltage. Both should be current or both should be voltage. The comparator is usually a rectifier bridge type rectifier. The differential relay measures the vector difference between two similar electrical quantities. It is mainly used for protection of generators, transformers, etc. against internal faults. It is very compact, highly sensitive, high stable, low power consumption, and lower volt ampere burden. It cannot be used in large transmission lines as length of the line will be large. And normal case there will be large difference in current also. Next is distance relay. In case of transmission line, as the length of the line is very large, we are mainly using distance relay for the protection. A distance relay has the ability to detect the fault within a preset distance along the transmission line or power cable from its location. Early power line has a resistance reactance per kilometer related to its design, construction. So its total impedance will be function of its length. So for every power lines, there is a specified value of impedance, and it impedance is the function of length. When fault occurs, the impedance in the system changes. If there is some loads here, the impedance of the some system will be large. But when there is a short circuit occurs, the impedance will be reduced as this part of the system is not connected, or there is some other short circuit path. So impedance of the system changes during the fault condition. So distance relay usually measures the impedance of the system. So it looks at both voltage and current and compares these two quantities based on the Ohm's law. E by I gives impedance value. So impedance value is measured and it is compared with predetermined value, and it can be done by measuring of impedance, reactance or admittance. In static comparators, two input quantities, either V or I. Here the voltage and current are given, but any one quantity is converted to, if it is voltage is converted to its proportional current, and at the impedance unit measuring unit both will be current quantities. This is called distance relay, which measures the impedance, and it is mainly used for transmission lines. These are about static relays. Now we can see numerical relay or microprocessor based relay. This is the block diagram of a numerical or microprocessor based relay. There will be current transformers for measuring the current. Then in microprocessor based relay, microprocessors are mainly operated by current values, voltage values, not the current values. So always there will be a current to voltage converter, and microprocessor will work suitably at the DC values. So there will be a rectifier for converting AC to DC. Both current transformers will have current to voltage converter and rectifier, and two inputs are given to the multiplexer. And as the microprocessor is a digital device, there will be an analog to digital converter for converting these analog quantities into digital values. And these digital outputs are given to the inputs of microprocessors. Then there will be a pre-programmed functions in the microprocessor depending on the application. That programs According to that programs, the microprocessor will work and there will be a set value of current or voltage. At that value, the microprocessor will send a trip signal to the circuit breaker. So numerical relay is the latest development in the area of power system protection. Numerical relay, which is measured AC quantities, are sampled and converted into numerical data and is processed by making it processed to make the trips decisions. Numerical relays are based on numerical devices such as microprocessors, microcontrollers, digital signal processors, etc. The output of current transformer line is given to the input receiver block where the signal is processed. Then signal processing includes overvoltage protection, rectifier, smoothing filters, auxiliary current transformers, etc. Usually the signal is an analog signal which is converted to digital and which is the acceptable form of microprocessor. And microprocessor is the block of decision making. The received digital signal is compared with the reference to generate the appropriate tripping signal. So numerical relay are different types depending on the application. Inverse definite minimum time over current relay, definite minimum time over current relay, phase comparator, reverse power relay. Similar to static relays, different types are there. The operating time of different values of current are calculated and tabulated. These values are stored in the memory as predetermined information. The microprocessor obtains the required signals to obtain a particular relaying characteristics by sending proper commands to the multiplexer. The microprocessor receives signals only in voltage form. So there is a current to voltage converter and the current is converted to voltage in the proportion of load current. This voltage is converted to DC by using the rectifier as we explained in the diagram. Is converted to DC and it is given to the multiplexer. Then there is analog to digital converter which makes the digital signals and it is given to the microprocessor which makes the decision and sends the tripping signal to the circuit breaker. This is the operation of microprocessor based relays. The main advantages of microprocessor based relays are they are very efficient, reliable, highly accurate, very fast in operation. And the main advantage is it is programmable in nature or it is very flexible. By changing the program in the microprocessor, we can use these relays for any type of applications. And a unit can perform transmission of several systems. It can use for any type of systems by changing the programs. And it is economical for large systems and useful for centrally coordinated backup protection. If it requires a highly complicated backup protection with adjusting the times and all, the microprocessor based relay is more suitable. The only care that must be taken is that microprocessor unit must be properly shielded as it get affected by external interference and environment. So, and also proper care of earthing must be taken. These are about microprocessor based relays. So, we have discussed about static relays and microprocessor based relays.